For question 27, right, when sodium is burnt in air, a mixture of sodium oxide and sodium peroxide is formed. Okay, so you burn sodium in air, sodium oxide and sodium peroxide is formed, right? It reacts with water to form these reactants over here. I highlight them because these are important for later. Okay, calculate the relative. It will help you calculate the relative amounts of these two oxides when sodium is burnt. Okay, the mixture obtained from burning a sample of sodium. So after I burn this sample of sodium, I'll get sodium oxide and sodium peroxide, and this sodium oxide and sodium peroxide is dissolved in water. So first, you burn sodium in air. Then after that, this mixture that I get, okay, this mixture will contain Na2O as well as Na2O2. You dissolve in distilled water and made up to 100 cm cube, okay, to give you a solution H, right? So this means that solution H will contain NaOH plus H2O2. Okay, the next part of the question, they say 25 cm cube of solution H is then titrated with 0.100 dm cube of HCl, okay, and then 22.5 cm cube of acid is required to reach the end point. Okay, so in this case, you know, this NaOH is then reacted, the NaOH produced reacts with HCl. Okay, so this is one reaction that you probably will want to take note that you're gonna balance later. Okay, another thing to take note is that when you see that initially it was 100 cm cube and now suddenly it's 25 cm cube. Okay, so there's a certain kind of sampling going on over here. So we are going from 100 cm cube to 25.0 cm cube. Okay, then afterwards the H2O2 content of solution H is found by the titration with 25.0 cm cube with KMnO4 concentration, and they say 10.0 cm cube of KMnO4 is required, and the equation is given below already. Okay, so right, so you notice here there's also another sampling going on over here from here all the way to here. Okay, another sampling from 100 cm cube to 25.0 cm cube. Okay, just take note there's no dilution over here, although they say made up to 100 cm cube. Okay, the problem is that we are dissolving the solid inside this 100 cm cube already. So when you dissolve solids in 100 cm cube of distilled water already, there's no dilution. There's only dilution if you were to have an initial volume of a certain solution and then you continue to add water into it. Okay, so there's a difference between preparing stock solution from solid versus preparing a diluted solution, and this will have been the dilution process. Okay, maybe if I were to draw, right, you're adding the solid inside, okay, and then you add water, but then for dilution is that inside already contains a certain volume and then you will want to add water inside. Okay, so there's a clear difference between these two processes over here. Okay, so first of all, using the results from HCl titration, calculate the total amount of NaOH in moles in 100 cm cube of solution H. Okay, so we need to write our equation first. The only equation you have to write NaOH plus HCl, and this gives you NaCl plus H2O. Okay, so it's already balanced already. We go on to see if there's any excess or limiting reagents. So the thing is that for reaction 1 and reaction 2, which is this permanganate reacting with hydrogen peroxide, right? The thing is that when you have a titration reaction, you confirm know that it is a complete reaction. So there is no excess or limiting reagent over here. Okay. Then next we were to apply the formulas. Okay. So what data I'm given over here for part A, right? Okay. So for part A, what data I'm given? I'm given the volume of acid. Okay. 22.5 cm cube. I'm also given the concentration of HCl, which is 0.100 mole per dm cube. So I'm given also the initial, basically the volume of NaOH after sampling, which will be 25.0 cm cube, and the volume of NaOH before sampling, which is 100 cm cube. Okay, so working with these numbers, you can clearly know, okay, volume and concentration, you can just multiply them together to find out what is the number of moles. Okay, 2.5 over 100, 1000 times 0.1. Okay, so this one will give me 0.002250 moles. Yeah, so notice even though it's an exact value, I still express it to 4SF. Yeah, I still express it to 4SF, right? Then the next part is, okay, so you want to find out the number of moles in 100 cm cube. I find out the number of moles in 25.0 cm cube. So remember, this is 25.0 cm cube. So the fact that the mole ratio is 1 to 1, it will still be the same. Okay, then if I want to go to 100 cm cube, right, I'll take this number and multiply by a scale factor. So this scale factor is 100 over 25.0 because you're taking the bigger volume dividing by the smaller volume, right? Alternatively, you can find the concentration of NaOH inside 25.0 cm cube, and because the concentration of NaOH in 25.0 cm cube is the same as 100 cm cube, then you can find out the number of moles of NaOH. Okay, so an alternative method would have been finding the concentration in 25.0 cm cube, which is also equals to the concentration in 100 cm cube. Okay, so you take this divided by 25.0 over 1000. And this gives you 0.0900 mole per dm cube. And then next, you want to find out the number of moles in 100 cm cube. You take this concentration, which is the constant, multiply by the volume, which is 100 over 1000. (0.009000 mole). Okay, so this one is also 0.009000 moles. So essentially both methods, you realize that you're dividing by 25 cm cube. You're dividing by 25 cm cube, and then you multiply by 100 over here. So you're multiplying by 100 later on. So essentially both methods are essentially the same. Okay, it's just making use of the concept that sampling the concentration stays constant during sampling. Whereas for dilution, the number of moles of the substance stays constant. Okay, and then you get the answer over here. Okay, so for the next part B, right? Calculate the number of moles of H2O2 in 100 cm3. So we also need to take note of sampling again. Okay, so what we are given over here is that we have okay, so we have KMnO4 0.0200 mole. This one will have been KMnO4, right? And then the volume of KMnO4 used up would have been 10.0, okay, 10.0 cm cube. Okay, and then when you check, okay, so you check over here, volume of H2O2 after sampling will have been 25.0, before sampling is 100 cm cube. Okay, so what you can do next, so you have this equation over here, 2MnO4, I think there's a error, so 2MnO4 minus plus 5H2O2 plus 6H plus, okay, 2Mn2 plus 5O2 plus 8H2O. So the small error over here is that you need to put the minus sign next to MnO4. Okay, so what information you have at your arsenal, you can actually calculate for the number of moles of MnO4 minus, right? Just take note, actually KMnO4, right? KMnO4 is subdivided into K plus MnO4 minus. So in that sense, right, if you're gonna calculate for the number of moles of potassium manganate, you're also gonna calculate for the number of moles of manganate ions. Okay, so over here I can just say NMnO4 minus equals to NKMnO4, right? And this will equal to 10.0 over 1000 multiplied by 0.0200 mole per dm cube. So this gives you 0.0002000 moles. Okay, then what's next is that we can actually use this. We want to go to H2O2, so the ratio over here is 2:5, right? So H2O2, this one is in 25.0 cm cube. It's good to label, it's a very good practice to label what these numbers refer to, and especially in what volume, okay, so that you are aware of this, okay, and then you won't make any careless mistakes. Okay, so it will be multiplied by 5/2, because you divide it by 2 first and then multiply by 5, then get 0.0005 thousand mole. Okay, next you want to do the sampling, okay, in 100 cm cube now. So this is what I mean, when it comes to sampling or even dilution, you need to label what this number of moles or what is this concentration in what volume of solution. Okay, so in this case 0.0005 thousand multiply by 100 over 25.0, or you can use the other method that I have suggested. Okay, 100 over this one will have been 0.002 thousand mole. Okay, and that would have been your answer. Okay, part C now. Calculate the number of moles of Na2O and Na2O2 formed during the burning of the sodium sample. So when you see hence, it probably means you need to use the answers from the previous parts of the question. Okay, the previous parts of the question. Right, and how do you link this? Okay, so NaOH and H2O2, right? You can see over here, there's two reactions, okay, A and B. NaOH, H2O2, when you know what's the number of moles of H2O2, you can actually just directly find the number of moles of sodium peroxide over here. But the fact that these two reaction produces sodium hydroxide. So sodium hydroxide has two different sources where it comes from. It can come from either the reaction of Ne2O or the reaction of Ne2O2. This means you have to be very careful of this. So once you find out what is the number of moles of Ne2O2 reacted, you can find out what is the number of moles of NaOH produced specifically by Na2O2. Okay, and once you find out that, then you can take the total number of moles of NaOH minus of this to find out the number of moles of NaOH produced from Na2O. Okay, so I'll just erase this and then I'll just show you clearly what I mean by this. Okay, so I'll just bring this entire working down. Okay, so right, so knowing the number of moles of, so what was in the previous answer, okay, number of moles of H2O in 100 cm cube. Okay, then we'll label this in blue. Then I also have the number of moles of NaOH in 100 cm cube. Okay, so this one is 0.002 thousand mole. Is 0.009 thousand. Okay, so once I know the number of moles of, because only hydrochloric acid is produced from, only H2O2 is produced from Na2O2. That's why I can find out directly what is the number of moles of Na2O2 produced, which is 0.002 100 moles. Okay, then when we go on to the next part, right, keeping in mind this is the total number of moles of NaOH in 100 cm cube, and the fact that NaOH is produced both from Na2O and Na2O2. So this means that I want to know what is one of them. Okay, either this or this. And clearly I will have known what is the number of moles of NaOH produced from Na2O2 specifically only. So this one is 2 multiplied by 0.002 thousand moles. This gives me 0.004 thousand moles. Okay. And then if you want to know what is the NaOH produced specifically from Na2O, right? Just take the total minus the number of moles of NaOH produced from Na2O2. This is 0.005 thousand. Okay, and then when you want to calculate for the number of moles of Na2O, you will just take this divided by 2. This gives you 0.00250. Actually, you just need to round it off to 3SF. So you get these as your final answers. Okay, keeping in mind that your final answers should be rounded off to 3SF. Okay, and that is for part C.